Good morning everyone. Now we discuss internal structure of human heart. You already know 2 atria and 2 ventricles. 2 atria internally separated by interatrial septum. 2 atria internally separated by a membrane known as interatrial septum. Interatrial septum contain an aperture known as foramen ovalis. After birth, lungs are fully functional. The lungs press the atria. Atria create pressure on interatrial septum. Now the foramen ovalis converted into a thick circular patch known as fossa ovalis. Before birth it is a opening known as foramen ovalis. After birth it is a thick circular patch known as fossa ovalis. But in some infants, foramen ovalis is not completely converted into fossa ovalis. That is known as hole in the heart. So we heard sometimes, some children born with hole in the heart. That is nothing but the foramen ovalis is not completely converted into fossa ovalis. Now the cardiologist by a surgery, that person rectify this defect. So in some persons foramen ovalis not converted into fossa ovalis. This condition is known as patent foramen ovalis. Patent foramen ovalis. Next point, right atrium contain 3 openings, left atrium contain 4 openings. Superior vein cava, inferior vein cava. Pour the blood into right atrium through separate apertures. Superior vein cava. Inferior vein cava. So opening of superior vein cava. Superior vein cava. Superior vein cava collect blood from head, thorax and hands and pour the deoxygenated blood into right atrium. Inferior vein cava collect blood from legs, abdomen and release the blood into right atrium through an aperture. This aperture is guarded by a valve known as Eustachian valve. Eustachian valve. In embryonic stage, the Eustachian valve is functional. At the time inferior vein cava release the blood into left atrium. So in embryonic stage, left atrium contain mixed blood. Embryo means only 2 months. The development of human embryo, first 2 months is known as embryo. The developmental stage of human, first 2 months is known as embryo. From 3rd month before delivery is known as fetus. So first 2 months only, Eustachian valve direct the inferior vein cava into left atrium. Truly left atrium contain oxygenated blood. In embryonic stage, left atrium receive oxygenated blood from lungs and deoxygenated blood from inferior vein cava. In fetal stage, Eustachian valve is non-functional. In fetal stage, Eustachian valve is non-functional. Another opening is opening of coronary sinus. Opening of coronary sinus. The coronary sinus is guarded by sebaceous valve. Sebaceous valve. 4 coronary veins collect blood from wall of heart, and these 4 coronary veins release the deoxygenated blood in the concavity present in the wall of heart. That concavity is known as coronary sinus. Coronary sinus pour the deoxygenated blood into right atrium through an aperture. This aperture is guarded by sebaceous valve. So sebaceous valve allow the flow of blood from coronary sinus into right atrium and prevent the backward flow from right atrium into coronary sinus. Left atrium contain 4 openings. Openings of pulmonary vein. Opening of pulmonary vein. These are the 2 pulmonary veins. So these pulmonary veins arises from the left lung. These 2 pulmonary veins arising from the right lung. So 4 pulmonary, from right lung 2 pulmonary veins arise, from left lung 2 pulmonary veins arise, 4 pulmonary veins pour the oxygenated blood into left atrium through separate apertures. So these are the 2 pulmonary veins arise from the right lung. These 2 are the pulmonary veins arise from the left lung. All the 4 veins release the blood into left atrium through separate apertures. So right atrium receive deoxygenated blood, left atrium receive oxygenated blood. Right atrium contain 3 openings. Opening of superior vein cava, opening of inferior vein cava, opening of coronary sinus. Left atrium contain 4 openings. Openings of 4 pulmonary veins. Next point. Atria and ventricles internally separated by a septum known as atrioventricular septum. Atrioventricular septum. So it is the atrioventricular septum. Atrioventricular septum contain openings. One opening present in atrioventricular septum between right atrium and right ventricle. This opening is known as right atrioventricular aperture. Right atrioventricular aperture. Right atrioventricular aperture guarded by tricuspid valve. Tricuspid valve. So valve function is the same. Prevent the backward flow. Tricuspid valve allow the flow of blood from right atrium into right ventricle. Prevent the backward flow from right ventricle into right atrium. In the atrioventricular septum, opening present between left atrium and left ventricle is known as left atrioventricular aperture. Left atrioventricular aperture is guarded by bicuspid valve. The bicuspid valve also known as mitral valve. Mitral valve. Atria and ventricles internally separated by a membrane known as atrioventricular septum. Atrioventricular septum contain 2 openings. The opening present between right atrium and right ventricle is known as right atrioventricular aperture. Right atrioventricular aperture is guarded by tricuspid valve. Similarly, the opening present between left atrium and left ventricle is known as left atrioventricular aperture. It is guarded by bicuspid valve. Bicuspid valve also known as mitral valve. The inner surface of ventricle contains several folds known as trabeculae corneae. The deep folds are known as papillary muscles. 2 types of folds, shallow folds. Inner wall of ventricle contains shallow, means not deep folds, known as the trabeculae corneae. Deep folds are known as papillary muscles. Heart strings are the cartilaginous structures. The heart strings connect the papillary muscles of left ventricle to bicuspid valve. The heart strings present in the right ventricle connect the papillary muscles to the tricuspid valve. What are heart strings? Heart strings are made up of cartilage. One end they connected to papillary muscle, another end they connected to atrioventricular valves. What is the use of papillary muscles and heart strings? When the ventricle undergo contraction, at the time tricuspid and bicuspid valves may enter into atria and reduce the area of atria. When the ventricles undergo contraction, papillary muscles and heart strings prevent the entry of tricuspid and bicuspid valves into atria. That is the function of papillary muscles and heart strings. So next point is pacemakers. What is pacemaker? The part of the heart where wave of contraction begins. The part of heart where wave of contraction begins is known as pacemaker. Two pacemakers are present. One is sinoatrial node. Or SA node. Another is atrioventricular node. Atrioventricular node. The pacemakers are special type of cardiac muscle, also known as nodal tissue. Nodal tissue. Special type of cardiac muscle, nodal tissue. SA node is present, attaches to anterior right side of right atrium. AV node is attaches to posterior left side of right atrium. If the muscle act as a pacemaker, known as myogenic pacemaker. If the muscle act as a pacemaker, myogenic pacemaker. The heart contain myogenic pacemaker, known as myogenic heart. In all chordates, myogenic heart. Most of the invertebrates, neurogenic heart. Neuron and nerve act as a pacemaker. Neurogenic heart. The wave of contraction begin in the SA node and it travel in the form of concentric rings all over the atria. Atria undergo contraction. During atrial contraction, the wave of contraction enter into interatrial septum. From interatrial septum, AV node. AV node receive the wave of contraction. AV node receive the wave of contraction. From the AV node, AV bundle arises. The muscle arising from the AV node, AV bundle. AV bundle enter into interventricular septum. The membrane divide the two ventricles internally, known as interventricular septum. In the interventricular septum divides into two branches, right bundle office, left bundle office. Right bundle office enter into right ventricle, left bundle office enters into left ventricle. From the bundle office, fine branches arise, known as Purkinje fibers. The Purkinje fibers spread the wave of contraction all over the ventricle. AV node act as a relay station. So wave of contraction not generated in the AV node. Generally we call two pacemaker, but wave of contraction generated in the SA node only. AV node simply transfer the wave of contraction received from the SA node to ventricles. That's why AV node act as a relay station. Once again, pacemaker. The part of the heart where wave of contraction begin is known as pacemaker. Heart has two pacemaker. One is SA node and another one is AV node. SA node means sinoatrial node. Sinoatrial node attaches to anterior right side of right atrium. Atrioventricular node attaches to posterior left side of right atrium. So these pacemakers are special type of cardiac muscle known as nodal tissue. SU node generate the wave of contraction. The wave of contraction spread all over the atria. Now the atria undergo contraction. When the atria undergo contraction, the wave of contraction enter into interatrial septum. From the interatrial septum, AV node receive the wave of contraction. AV node act as a relay station. From the AV node, AV bundle, muscle bundle arising from the AV node is known as AV bundle. AV bundle enter into interventricular septum. In the interventricular septum, AV bundle is in the form of two branches, right bundle of his, left bundle of his. Right bundle of his innervate into right ventricle, left bundle of his innervate into left ventricle. The fine branches arising from the bundle of his known as Purkinje fibers. Purkinje fibers. The Purkinje fibers spread the wave of contraction all over the ventricle. Sometimes they may ask, so arrange the following structures in a sequence regarding conduction of contraction. SA node all over the atria, AV node, AV bundle, bundle of his, Purkinje fibers. From the Purkinje fibers, the wave of contraction spread all over the ventricles. Next one is two arches arising from the ventricle. One arch from the right ventricle, another arch from the left ventricle. The arch arising from the left ventricle is known as left systemic arch. Left systemic arch. Left systemic arch arising from the anterior right side of left ventricle. At the base of left systemic arch, semilunar valve is present. It contains three half moon shaped, but that is only one valve, semilunar valve. So when the ventricle contract from the left ventricle through an aperture, the oxygenated blood enter into left systemic arch. The left systemic arch from the ventral surface travel to dorsal surface and continued as dorsal aorta. The left systemic arch arising from the anterior right side of left ventricle. At the base of left systemic arch, semilunar valve is present. So later, from the ventral surface, it traveled to dorsal, continued as dorsal aorta. From the dorsal aorta, several paired and unpaired arteries arise. They supply oxygenated blood to various organs of the body. Next one, the arch arising from the anterior left side of right ventricle is the pulmonary arch. Pulmonary arch arise from the anterior left side of right ventricle. At the base of pulmonary arch also semilunar valve is present. When the ventricles contract, the deoxygenated blood from the right ventricle enter into pulmonary arch. Pulmonary arch divides into two pulmonary arteries, right pulmonary artery, left pulmonary artery. Right pulmonary artery supplies deoxygenated blood to right lung. Left pulmonary artery supplies deoxygenated blood to left lung. Pulmonary arch and left systemic arch connected by a fibrous strand known as ligamentum arteriosum. Ligamentum arteriosum. Left and pulmonary arch and left systemic arch connected by a fibrous strand externally. This fibrous strand is known as ligamentum arteriosum. So, in adult human, 11 openings present in the heart, 3 openings in the right atrium, 4 openings in the left atrium, In the atrioventricular septum 2, 3 plus 4, 7, 8, 9. Right ventricle open into pulmonary arch through 1. Left ventricle open into left systemic arch through 1. So in adult human, heart has 11 openings. In embryonic stage and fetal stage, 12 openings. In the interatrial septum, foramen ovale is present. So before birth, human heart has 12 openings. After birth, human heart has 11 openings. Internal structure of heart of human being. With the help of diagram, you can easily understand the concept. Once again, I revise the internal structure. Right atrium and left atrium separated by a membrane internally. This membrane is known as interatrial septum. Before birth, opening present in the interatrial septum is known as foramen ovalis. After birth, lungs are fully functional. The lungs press the atria. At the time, the foramen ovalis converted into fossa ovalis. But in some infants, foramen ovalis not completely converted into fossa ovalis. So generally, people called some children born with hole, that hole in the heart. The hole in the heart is nothing but foramen ovalis not converted into fossa ovalis. Now the cardiologist, by a surgery, he rectify this defect. Otherwise, the lifespan of infant born with hole in the heart may be 1 to 1.5 years only. Right atrium contain 3 openings. Opening of superior vena cava, opening of inferior vena cava, opening of coronary sinus. Superior vena cava collect blood from head, thorax and hands and pour the deoxygenated blood into right atrium. Inferior vena cava collect the blood from legs, abdomen, pour the deoxygenated blood into right atrium through an aperture. The opening of inferior vena cava guarded by Eustachian valve. This valve is functional only in embryonic stage. In embryonic stage, Eustachian valve direct the inferior vena cava into left atrium. So in embryonic stage, left atrium contain mixed blood. In fetal stage, after birth, left atrium contain oxygenated blood only. Eustachian valve is non-functional in fetus and birth, after birth. In the fetal stage and after birth, Eustachian valve is non-functional. Next one is opening of coronary sinus. 4 coronary veins collect blood from wall of heart. They release the deoxygenated blood in the concavity of wall of heart. That concavity present in the wall of heart is known as coronary sinus. Coronary sinus pour the blood into right atrium through an aperture. This aperture is guarded by sebaceous valve. Function of sebaceous valve is allow the blood from coronary sinus into right atrium, prevent the backward flow from right atrium into coronary sinus. Next one is left atrium. Left atrium contain 4 openings. From the right lung, 2 pulmonary veins arise. From the left lung, 2 pulmonary veins arise. The 4 pulmonary veins pour the oxygenated blood into left atrium through separate apertures. Next one, atria and ventricles internally separated by a membrane. Atria and ventricles internally separated by a membrane known as interatrial is known as atrioventricular septum. Atrioventricular septum. Atrioventricular septum contains 2 openings. The opening present between right atrium and right ventricle is known as right atrioventricular aperture. Right atrioventricular aperture guarded by tricuspid valve. Cusp means So that is a flap, 3 flaps in that valve, tricuspid valve. Opening present between left atrium and left ventricle in the atrioventricular septum is known as left atrioventricular aperture. Left atrioventricular aperture guarded by bicuspid valve. Bicuspid valve also known as mitral valve. Inner surface of ventricle contain folds. The shallow folds means not deep. The shallow folds are known as trabeculae cardiae. Deep folds known as papillary muscles. Cartilaginous structures are heart strings. One side of cartilaginous strings or heart strings attaches to papillary muscle. Another side attaches to cuspid valves. So the heart strings present in the left ventricle, one side connected to bicuspid valve. The heart strings present in the right ventricle, one side connected to papillary muscle, another side connected to tricuspid valve. What is the function of papillary muscles and heart strings? When the ventricles undergo contraction, the papillary muscles and heart string prevent the protuberance of tricuspid and bicuspid valves into atria. If cardiac tendineae, if heart strings and papillary muscles are absent, when the ventricles undergo contraction, cuspid valves enter into atria and reduce the volume of atria. So due to presence of papillary muscles and heart strings, atrioventricular valves never enter into atria. In this manner, avoid the entry of cuspid valves and avoid the reduction of volume of atria. Next point is nodal tissue, special type of cardiac muscle known as nodal tissue. One is SA node, sinoatrial node. Another one is AV node, atrioventricular node. Sinoatrial node attaches to the anterior right side of right atrium. Atrioventricular node attaches to posterior left side of right atrium. SA node is the true pacemaker. AV node acts as a relay station. Simply it transfers the wave of contraction to ventricles. That's why AV node acts as a relay station. Wave of contraction generated in the SA node. The wave of contraction spread in the form of concentrical rings all over the atria. At the time atria undergo contraction. During atrial contraction, the wave of contraction enter into interatrial septum. From interatrial septum, AV node receive the wave of contraction. The muscle bundle arises from the AV node, known as AV bundle. AV bundle enters into interventricular septum. The membrane internally separates the two ventricles, known as interventricular septum. In the interventricular septum, AV bundle divides into two branches, right bundle of his, left bundle of his. Right bundle of his innervate into right ventricle, left bundle of his innervate into left ventricle. Fine branches arising from the bundle of his known as Purkinje fibers. Purkinje fibers spread the wave of contraction all over the ventricle. Next point is arches. From the right ventricle, pulmonary arch arises. From the left ventricle, left systemic arch arises. Left systemic arch arises. At the base of pulmonary arch, semilunar valve. At the base of systemic arch, semilunar valve is present. Pulmonary arch and left systemic arch connected by a fibrous strand known as ligamentum arteriosum. Ligamentum arteriosum. When the ventricles contract, from the right ventricle, deoxygenated blood enter into pulmonary arch. From the left ventricle, oxygenated blood enter into left systemic arch. Left systemic arch from the ventral surface travel to dorsal and continued as dorsal aorta. From the dorsal aorta, several paired and unpaired arteries arise. They supply blood to various organs. So number of valves in the heart of man, 6 valves: Eustachian valve, Sebaceous valve, tricuspid valve, bicuspid valve, 2 semilunar valves, 6 valves. Number of functional valves in adult, 5 valves. Eustachian valve is non-functional. Sebaceous valve, tricuspid valve, bicuspid valve, 2 semilunar valves. 5 valves are functional and 1 valve is non-functional. Number of functional valves in human embryo, 6 valves. Eustachian valve also functional during embryonic stage. So one more point is various layers present in the heart wall. The layer present, the fibrous layer present around the heart is known as fibrous pericardium. Inner to fibrous pericardium, serous pericardium. The fibrous layer present around the heart is known as fibrous pericardium. Inner to fibrous pericardium, serous pericardium is present. The serous pericardium split into 2 layers: outer parietal layer, inner visceral layer. Parietal layer attaches to fibrous pericardium. Visceral layer attaches to the wall of heart. The cavity present between parietal layer and visceral layer known as pericardial cavity. Pericardial cavity filled with pericardial fluid. The pericardial fluid protects the 4 chambers of heart while they are working. So prevent friction between the four chambers, and prevent friction with the heart and neighboring visceral organs. The outer fibrous layer is fibrous pericardium. Inner to fibrous pericardium, serous pericardium. Serous pericardium divided into outer parietal layer, inner visceral layer. Parietal layer attaches to fibrous pericardium. Visceral layer attaches to wall of heart. The visceral layer also known as epicardium. Inner to epicardium, myocardium is present. That is the heart muscle, myocardium. It is responsible for contraction and relaxation. Inner to myocardium, endocardium. Endocardium is a epithelial cells arranged in the form of a single layer. So various layers from outer to inner in the heart of human. Fibrous pericardium, parietal layer, pericardial cavity, visceral layer or epicardium, myocardium, endocardium, or various layers from inner to outer. Endocardium, myocardium, epicardium, pericardial cavity, parietal layer, fibrous pericardium. These are the different layers from inner to outer or outer to inner. Internal structure of heart of human being. External structure. Once again I revise external structure. Four-chambered heart, two atria, two ventricle. Right atrium is bigger than left atrium. Atria and ventricle externally separated by coronary sulcus. Coronary sulcus. Two ventricles externally separated by interventricular groove. Interventricular groove. Coronary artery and its branches present in the interventricular groove. Anterior part of each atrium contain a lobe-like structure known as auricular appendix. Auricular appendix increase the area of atria. Heart is present in the empty place between lungs. The empty place present between the lungs known as mediastinum. Known as mediastinum. Heart is present in the mediastinum. So the size of heart is a clenched fist, tightly held fist, clenched fist. Mediastinum. It works tirelessly from birth until death. Four-chamber, right atrium, left atrium, right ventricle, left ventricle, right atrium bigger than the left atrium, left ventricle bigger than the right ventricle. Atria and ventricles externally separated by coronary serous. Atria and ventricle internally separated by atrioventricular septum. Two ventricles externally separated by interventricular groove. two ventricles internally separated by interventricular septum. Groove external separation. Septum internally separated. The membrane separate the organ externally. Groove internally septum. Coronary artery and its branches lodged in the interventricular groove. Anterior part of atria contain earlobe like structures known as auricular appendix. Auricular appendix increase the area of atria. So tomorrow we discuss working of heart, double circulation.